A blessed day to everyone. My name is Felicity de la Cruz, and today I am honored to present my final project, Inventory Management System. Inaccurate stock counts and ghost inventory cause significant financial loss for businesses. My system addresses this by providing a single source of truth. It ensures every item is accounted for in real time, preventing overstocking and stockouts through automated tracking and strict data validation. My system is built upon four primary functional pillars. First is product intelligence. This is where we manage item details, pricing, and categories. I implemented a soft delete or archiving concept here. Instead of permanently deleting items, which would break historical sales records, the system archives them, keeping the database clean while preserving history. Second is the sales and outflow, a dynamic module for creating customer orders. It features automatic stock reduction, ensuring inventory levels are updated the moment a sale is made. Third is the procurement and inflow. This manages restocking from suppliers and ensuring the business never runs out of critical items. Fourth is the administrative security. Since inventory data is sensitive, I included an admin level where only authorized personnel can manage the users. The primary objectives are to provide a user-friendly interface that handles complex database transactions, to enforce strict validation rules such as preventing sales that exceed current stock, and to maintain 100% data integrity through a centralized database. Technically, the system follows a client-server architecture. For the front end, I chose C# Windows Forms. I selected this for its robust UI controls, particularly the data grid view, which is essential for handling multi-item transactions. For the backend, I utilized MySql, a relational database known for its speed, security, and reliability. A critical part of my coding approach was the development of a dedicated database connection class. Instead of rewriting connection strings in every form, I encapsulated the logic here. This ensures a secure communication between the app and the server, follows the don't repeat yourself principle, and makes the system much easier to maintain or scale in the future. The backbone of our system is its relational database design. For the key entities, we have a main table such as the product, sales order, sales items, purchase order and purchase items, user and category, and supplier. We implemented a one-to-many relationship between the orders and the items. For example, one sales order can contain multiple sales items. We also have a relationship wherein the category is aligned with products the user has chosen. A critical part of our design is the use of foreign keys. The product ID in our sales and purchase tables acts as a bridge to the product master table. The category ID as well is aligned to the products. This ensures that the system never records a transaction for a non-existent product, maintaining strict referential integrity. By separating order headers from order details, we reduce data redundancy and optimize the system for faster queries. We also use a tiny int as well for soft deleting like 0 and 1. Now let's proceed to the actual system demonstration. To begin, I will log in using the admin credentials. Our first stop is the product section. In Manage Categories, I'll add a new category. You'll see that category edits reflect in the table in real time, and I can also delete categories as needed. Now, let's add a new product. I'll assign it a category, price, and initial stock. Upon saving, it is immediately populated in the main table. Notice how I can also edit existing products and the changes reflect instantly in the main table. A key feature is the Adjust Stock module. By selecting a category, the system filters products for faster searching. We can manually add stock or perform deductions. For deductions, I've required a reason field to ensure accountability for damaged or lost goods. Notice how I can also add stocks aside from deductions. To ensure the system remains efficient as the inventory grows, I've included a search text box that allows users to instantly filter products by name or category. I've also implemented an automated archive system. If a product's stock hits zero, it is automatically moved to the archive section. This keeps the active list clean. Once we restock an archived item, it seamlessly restores back to the product section. Moving to the sales section, you can use the search text box to quickly locate existing orders by ID or customer name. The new order interface allows for multi-item transactions, calculating subtotals and the grand total in real time. Orders can be edited while pending, but once marked as completed, the record is locked and the stock is officially deducted. Crucially, I have implemented strict data validation. The system will block any transaction if the ordered quantity exceeds the current available stock. This prevents negative inventory and ensures our physical and digital records stay synchronized. In the purchase section, we manage supplier relationships. So now we are adding a new supplier. We can also update the supplier's information. Similar to sales, we can process multi-item purchase orders and search through our procurement history using the built-in filters. Once the status changes to received, the stock levels are automatically replenished. Similarly, any modifications to suppliers are reflected immediately and existing entries can be deleted with a click. The support section handles user management. Using role-based access control, only admins can access this area to add users, reset passwords, or monitor lost login timestamps. Finally, our dashboard provides a real-time summary of total orders, products, and stock levels reflecting today's changes. It also highlights top-selling products, transforming raw sales data into actionable business insights. If I log out and log in as a standard user, you will see that the support tab is strictly restricted. Now let's transition to MySql Workbench to confirm that every piece of data we handled is correctly stored in the backend. First, you will notice that I have an additional connection configured here. This was used for remote access testing, allowing me to verify that the system remains functional when accessed by other devices on a network, simulating a real-world multi-user environment. So as we look at the tables, we can see the system's logic in action. Here is the bed and garden category we added. Notice the use of tiny int 0 and 1 for the status. This is a more efficient way to manage active or archive records than using text. All information entered is present here as well. In the supplier table, the new contact details are saved, and in the user table, we can see the updated login timestamps and user roles we managed earlier. In the purchase order and sales order tables, notice that we use supplier ID and category ID as foreign keys. By storing IDs instead of repeating names, we eliminate redundancy and ensure the database remains fast and professional. So the fact that these entries from the sales transactions to the new supplier profiles are reflected here instantly proves that our C-sharp application and MySQL database are perfectly synchronized. This confirms that the system is not only user-friendly but also technically sound and data secure. Thank you. To wrap up, this project allowed me to apply theoretical database concepts to a practical business tool. We encountered several technical hurdles, most notably data type mismatches where we had to carefully cast database integers into C-sharp strings for display and foreign key constraint errors. These errors taught us that the importance of ensuring that parent records exist before child records are inserted. We solved this by implementing robust error handling and using SQL transactions to ensure that either the whole order is saved or nothing at all, preventing partial data from corrupting our database. In the future, I hope to add a reporting engine to generate monthly sales charts and a transaction history to monitor the sales and purchase of the orders. This concludes my presentation. Thank you for your time.